So when last we met, we learned about the various algebraic laws that apply to Boolean algebra, and I promised you some examples of how to use them. Well, here's, let's see here, x times x prime plus y. How would you reduce that? First of all, you would use the distributive property, x x prime plus x y for the distributive. Law. And then x ANDed with its complement is always going to be 0, so this goes to 0, or x and y. And then 0 ORed with any value is that value, so it would be just x, y, x and y. So that's the negation and identity. Gives you those particular steps. Now something a little bit more complex. This is fairly simple and straightforward, just the distributive property and bringing it down a little bit. Something a little bit more complex, with three variables. X, Y, let me hold this so I can copy it down correctly here. Or x prime z, or yz. Now this isn't as obvious. To reduce this, you need to introduce an extra term to reduce it down. You can add to this term x or x prime, because x or x prime is always going to be 1, which is the identity, our negation law. And when you add, or when you and yz to 1, it is just yz. So that doesn't change. Adding the x plus x prime to the and, that this and here does not change the term. Okay. What this allows you to do then is distribute this, so it's x, y, or x prime z plus, or x, y, z, or x prime, y, z. Okay? So, that is the distributive law. This is negation and identity. And this is distributive. Then you could use the distributive again to factor out x, y, and xy from these two terms. So it would be xy and 1 plus z. Because this is x and y and 1. The 1 is implied. X, y, z. So you distribute out the x, y to be 1 plus z. Okay? That's these two. This is a implied 1. And these two go here. Now these two terms, you can factor out or distribute out the x prime z. They both have x prime z. So you have x prime z, and this is again implied a 1 plus y. Now, 1 ORed with any value is going to be 1, right? So these simplify to x, y, and 1 plus x prime z and 1, which just leaves you with x, y, or x prime z. I'm sorry? Yeah, that's all one process. This is the distributive law. And this is the, I looked it up in discrete structures material, universal bound law. 1 plus 1 ORed with any value is going to be that original value. Yeah. Oh, because the two factors have the two I just had the, yeah, they have both have x prime z, the x prime z, x prime z. The 1 is taking place of the y in that term. That's the word I was looking for, term. the common variables in the two terms are x prime and z. All right? Not as intuitive as the first problem, but you can see that this was, let's see here, 1, 2, 3, 4, 5, 6 gates here, and 1, 2, 3, 4 gates here. So it is a reduction by 50% or 33% to achieve the same logical equivalence. All right. It's the only two examples that I had that I didn't put in. Just at the request of at least a couple of students, there will be homework issued today on leaving class. Give those people that like to have practice and all that sort of stuff a chance to practice on some problems. It's not long, it's only 10 questions, and it'll be due on Monday, the following Monday. So, all right, next segment, minterms. A minterm is a term that has all the variables in the function ANDed together. This we saw before in creating expressions from truth tables. A Boolean function can be expressed from a given table by forming a minterm of each combination of the variables that produces a 1 in the function and then taking the OR of all those terms. That would be the sum of minterms. So let me get this. So we'll do a quick table here. Come on, don't die on me now. All right, so say these are your x, y, and z variables in the table. A 1 here would be x prime, y prime, z prime. X prime, y prime, z. X prime, y, z prime. X prime, y, z. X, y prime, z prime. X, y prime, z. X, y, z prime. And x, y, z. So if there's a 1 in this row of the function, this term will be in the Boolean expression. Okay? And these are called M0, M1, M2, M3, M4, M7. Now, when you have, say, let's say you have F, I'll put it over here, even though it's not standard practice. They have 1, 0, 0, 1, 0, 0, 1, 0, 0. Okay? So the sum of minterms would be the minterm matching for each one in the output column. So it would be x prime, y prime, z prime, or x prime, y, z, or x, y prime, z. Yeah, just as there's 3 ones in the output column, so it'd have 3 minterms, like here, like so. This can also be abbreviated using sigma notation because it's like a sum, like this the sigma notation you see in algebra and calculus. Sigma, and then that's 0, 3, and 5. Because these are 0, M0, M3, and M5. Now, converting to a sum of minterms form can be useful for creating a state table for the expression. So if you're given a expression in this form, you can easily match up where the ones are and create a state table from that expression. Of course, not every expression is given in those terms. Let's see here. I didn't have an example. No. Let's see here. This, let's see here. Let's say you have x, or y prime z. That's not in a sum of minterms form. So to easily create your state table, you could draw out the circuit diagram and trace all the lines and all that sort of stuff. But if you just do a little bit of manipulation, let's see, let's do xy. let's see here, x, y, z, or z prime, or y prime, z, x, or x prime. What I did is I took the term and the variable not in the term, I added the complementary form of it. So it'd be equal to 1. Likewise, this is missing the x variable, so I added the and of the x and x prime. Then you just do the distributive property out. X, y, z plus x, y, z prime plus y prime, or x, y prime z, and or x prime, y prime z. And there is your sum of minterms. And then you could then see that this is M7, X, Y, Z prime is M6, X, Y prime Z, X, Y prime Z is 5, and X prime, Y prime Z is 1. So the output for the table would be a 1 here, and 1, 1, 1, 0, 0, 0, 0. So that would be your state table. Just a matter of algebraically manipulating it into the sum of minterms form, getting those numbers, and matching them up on the state table. Let's see here. All right. Now there's as you may have guessed, with the complement of the minterm, it would be the max term. Now the max term, let me go ahead and, I'll go ahead and leave that there. The max terms are the ORs, OR expressions. And they're inverted from the minterms. So it would be x plus y plus z prime x plus y prime plus z x plus y prime plus z prime, and x prime plus y plus z. And let's see. All right. Those are your max terms. These are min terms. And these are max terms. A min term is an and. I'm sorry, that was min term. I need to go to the next page. Each Boolean expression can also be expressed as a product of max terms. You create a product of max terms by creating OR expressions for the rows in the state table that have an output of 0. Then you AND those terms together. The max terms are the complement of the min term of the same number. So we had this the previous expression on the board with those min terms, x prime, y prime, z, x, y prime, z, x, y, z prime, and x, y, z, or all those. The equivalent expression using max terms, you would look at the zeros in the state table. So first one would be x plus y plus z. And x or y prime or z. And x, y prime plus z prime. And finally, x plus y plus, x prime plus y plus z. But that represents the same as the previous sum of min terms. Like the sum of min terms, the product of max terms can be conveniently expressed using the pi notation, capital Pi, and that's capital M 0, capital M 1, 2, 3. So we're using 0, 2, 3, and 4. So the notation for the product of max terms would be P, like the product sign that you would use in algebra or calculus. Now, if you'll notice, the sigma notation is just the opposite. Instead of 0, 2, 3, 4, you recall that it was 1, 5, 6, 7. The terms that were not used in the product of max terms. Now, I do have an example of converting to a max term expression here. Well, go ahead and you do that example here. All right, so let me let's see here. XY, I need a new marker, plus Y, I'm sorry, X prime Z. Now, by the distributive law, you could go XY plus X prime and XY plus Z. Distribute the or across the and. Then the distributive law again, you get X plus X prime Y plus X prime and X plus Z Y plus Z. Doing the distributive law again, and this, you'll notice this term here is a value ORed with its complement, so that's going to be a 1. So that just cancels out. So you have these, a product of sums, but they're not minterms. So you, in each term, or the missing variable from each term, each sum term, 0, or with it 0. In the case of the first one, it would be X prime plus Y plus Z and Z prime. X plus Y, Y prime plus Z and X prime plus Y plus Z. because the z prime and y prime and x prime are zeros, it does not affect the or expression. The expression stays the same. Just adding the variable to the expression. The variables to the expression. And then, yeah. This part right here? Okay. You have the x prime y, or y, ORed with 0 is still x prime y, right? Z and not z is always 0, right? So you can add that to the or expression without changing the value of it. It's like adding the x or x prime to a AND expression does not affect the output of the AND expression. It's the same type of situation, only with ORs instead of ANDs. I don't really have room to do this, but to go through all this, but you could take this, kind of, it makes it for a big expression, but I'll just do the first term. Distribute this over this, and it becomes x prime plus y plus z, and x prime plus y plus z prime, because you distribute this over that. And you do the same with this, and this term and that term. And then you'll probably, and in this situation, you end up with some duplicate terms, which you can just eliminate the duplicates and have your final result, which is let's see here. Where are you? Where are you? Come on. Where's that? Oh, the final result is x plus y plus z and x y prime z and then x prime y z, y and z, yeah, y or z, x prime plus z, and the last term is x prime plus y plus z prime. Yeah. Yeah. It just running out of space on the board to distribute out these two terms as well. but you can see that this term is down here, this term is down here. There's a couple of duplicates in there that you can remove.
I get like most of the stuff, but except for the stuff under the, I know when you move this one where it says Y plus, how did you get that from?
Oh, with this?
Yeah.
From the here to here?
No, from that first part, from there to there.
Oh, okay. Distributed x prime over x and y. It gives you x plus x prime and x prime, but it should be x prime and or y.
So you just distributed over the two terms right there?
Yeah.
Okay. So basically what you did down here at the bottom, like with the...
Yes.
Okay.
Yeah, the distributive property is, distributive law is used quite a bit in these manipulations. Both the and over or and or over and. So, yeah. But the end result is zeros are max terms and ones are min terms. But it's two different ways of expressing the same function.